Hello, everyone. Thank you for joining us today. Really happy you could make it. If you don't know who I am, I'm Konstantin. I'm the technical trainer here at Shelly. And today is our part two of our series scripting with AI for Shelly. If you were here with us for the first time, for the first one, welcome back. Great to have you again. If this is your first time here, it's a great moment to join us because you picked a really good webinar to start with. Today, we're going to be talking about Shelly scripts and specifically how you can use AI to write your own scripts and your own lines of code without being a programmer, without having any kind of programming background, just using plain English language to write your own scripts. Now, I could try to run the whole technical side and aspect of things by myself, but actually I have here today with me someone who is much better suited for the job. Hello, Orlin. Orlin is our solution engineer. He's gonna be helping me today, showing us everything that I'm talking about right now, everything that I mentioned. So he was also leading the first webinar. So Orlin, great to have you back.
Thank you, Konstantin. Thank you for these greetings. I'm very happy to be here again. So we'll do some things that can be done with automations, but rather we will focus on the scripting more. And probably we should give some preparations to the people. And for this thing, we will step on step 2, which is the prerequisites. Simple steps that we thinking that you already have or probably should do. We are not focusing on actual environment setup because there's a plenty of videos into YouTube where you can see for yourself how to set it and manage on your particular machine.
Yeah, in the first webinar, yeah.
So we'll talk more about the Shelly related stuff and AI. On step 3, the task description, so the requirements that we will give to the AI that will help our job, and of course live demo. I will try to leave some space for Q&A.
Yes.
So please stop me if you think I'm exceeding too much on different topics, and I'm proposing to go to the prerequisites and see what is our audience should cover.
Yeah, so to recap, here's how we're going to spend our next hour here together. First, we're going to give you a little bit more context on what Shelly scripts actually are, and more importantly, why artificial intelligence in this case can change the game when it comes to using these scripts. Then Orlin is going to actually walk us step by step through the prerequisites, telling us what we need to have set up. As we said, we're not going to be going into details on how to set it up in this webinar because we already went through that in the first one, and there is a recording already uploaded to our YouTube channel, the Shelly Academy YouTube channel, and our Shelly Academy landing page. So you can go check it out there if you want to follow along. But if you already have all of these things ready and configured, it's going to be very easy for you to follow along today. After that, we're going to be talking about the task today. We're gonna explain what this thing on our table here actually is, and then we're gonna get to the best part, actually, the live demo itself, which is where Orlin is going to use an AI agent to write the script and achieve the goal that we have set today. Finally, of course, we're going to wrap it up as every session that we do. We're going to wrap it up with a live Q&A. This Q&A is going to be open throughout the whole session, so I encourage you guys to go and drop your questions as the session goes on, and we'll handle, of course, all of the questions at the end live. Okay, so let's start from the beginning, Orly, because we have people watching today with all different levels of experience. So if you could just take a minute to break it down for us in plain English, what is actually a Shelly script?
Our small devices have a really powerful processor inside, and instead of only communicating with our cloud or the infrastructure of our clients and partners, our device is having a runtime engine, which is providing running a small asynchronous programs, and the language that we decide to integrate in our ecosystem is basically JavaScript. There's a plenty of reasons why we're using JavaScript, but one of it is that it is easier to find someone to write on JavaScript rather than find one to write in C, C++, or Rust. So the JavaScript is really close to the people. And today's programs that we run on the JavaScript and the AI will actually write will be written in JavaScript and run by these two devices. So for the first device, we chose i4, which will be used as a source of
input reader.
Yeah, input reader, and this is our 4 manual inputs that can be that will signal the device. Of course, because we want to create a communication plan, the information from the i4 device will be sent to the 4 p.m. Device, and the outputs of the 4 p.m. Device are connected to these 4 light bulbs. It is not easy to see, but on the downside of our 4 p.m. device is actually connected nothing. So the physical switches of the 4 p.m. device are actually bypassed by sending signals from the i4. Common case scenario, the 4 p.m. can live in a cabinet and it might be responsible for the lighting of the site that we are working on, and the i4 device can live behind a standard wall switch where 4 clickable buttons are connected to the i4 and used later on for controlling the scenes that 4 p.m. will power up.
Exactly. I just want to quickly jump in here and say that in this case, we have chosen the Shelly i4 and the Pro 4 p.m. Just because these are the devices that we decided to use. And of course, we have the Pro 4 p.m. Because it has 4 outputs, and our Shelly i4 has
4 inputs.
4 inputs,
which is really easy to match.
But I just want to make it clear that you can use any 2 devices that you want, because the idea here is just to have a wireless communication. Using this script, we're going to wirelessly make the 2 devices communicate to each other without having them wired together in any way. So you can achieve this with any 2 devices that you want. You can do it with Shelly 1 p.m, with a dimmer as the output and the 1 p.m. as the input. You can do it with a Shelly plug as the output. Pretty much your imagination can run wild. Today we're just going to be exploring this concept of the 2 devices working together wirelessly without any kind of wires running through one to another. So, okay, we established what we're gonna be doing today, but can you please tell us and the audience what are they actually gonna need in order to be able to do this?
Of course,
as a setup.
So first things first, we chose Visual Studio Code because it's a really common integrated development environment. So the Visual Studio Code has something that is called extensions, and for this purpose I use several AI agents, Claude, Gemini, and Codex. For today's demo I will use Codex. So the Codex is part of the ecosystem of OpenAI and ChatGPT environment. So basically we will communicate with ChatGPT, something that is maybe the first brand that were so common into the AI market, and this is why I chose it today. Of course, don't forget that when you install the extension, yes, thank you, you should log into your system. This will allow the extension to communicate with the servers, and knowing that you especially is using this AI. So if the AI knows what is your preferences, your code style, or your requirements, or the way you're thinking, because they know how we think, this will help to generate helpful output that will be meaningful to the devices and to fulfill the requirements. For this purpose, I would like to continue with not only installing VS Code, logging in, and the working folder, so where the actual
project is going to be stored.
Yes, because for the next episodes, we will use the same folder for organizing the information from the devices to the devices and everything related to the network. And then the idea is that when you have an AI agent, you can think of it with a new colleague who knows nothing about you. And if you want the one to help you, you should be very specific of your requirements. So if For
And
example,
what
I
you
ask
need
you,
to do, yeah.
yeah, if I ask you for a coffee and you know nothing about me, you will bring me a long coffee. But I prefer an espresso. When I tell you to make me an espresso, you probably will bring me with a big cup because I didn't specify the cup of the coffee. So please, when you're creating prompts or creating an intention files later we call, create a really specific text that describe the entire task.
It's very important to establish
yes,
what you want to do
to
the
focus,
AI.
to take your thoughts, to focus and create a single thing. So it might be a longer than you expect. So it is not just it's dark here, make it switch on the lights, but instead it cover a lot more things. So in order to have a really nice live demo, I prepare in our dry run prompt that later on we will share with the one who would like to use it. So the prompt will be as a skeleton for the others, but again, don't take it too seriously. Just focus and create your own stuff. So I will copy it.
Yeah, it's trial and error. Yeah, I just want to add for the audience that now we have this demo already set up. Now I just turned it on so the device can come online. But it's very important, first of all, as a prerequisite to
switch on the power.
To switch on the power, yes, of course.
And the Wi-Fi.
And also the devices need your station, whatever you're going to be using as the PC or laptop for programming, for creating the scripts, it and the devices need to be on the same network. Because this is the reason we are actually using VS Code, or it can be VS Code or the local app for ChatGPT. It is because the web versions of these apps actually have very limited access, and they cannot access your network or your apps or your devices in any way. So that's why it's very important, first of all, to have the localized versions of these devices. It's also very important to have a network, of course, that you're going to be using to work. That network needs to have internet for the AI. And the devices need to be configured in your app and connected to that network. The reason for this being is that you actually need to give the AI some kind of IP addresses or some way for it to reference these devices. So as I said, your devices as a prerequisite, they need to be up and running and they need to be connected to the network.
Yeah.
You already mentioned the working folder, which is going to be basically what we're going to be using as, let's say, our desktop for the AI to do everything in. And I think this pretty much sums up.
Yeah. So let's paste the prompt and see what will happen. I'm very curious. When you have Shelly devices, please internet and power. This is the two main stuff. So I'm sending the prompt to the AI, and now I'm expecting to see the results. Don't forget that the Shelly UI is a dynamic UI. So when you go,
this is the web UI, correct?
Yeah, this is the
embedded web. I'm sorry.
This is the embedded web.
Excuse me, the embedded web. Yes.
So we can see basically what it is doing. So now the script is running, and because into the point 2 is set, delete all existing local scripts from both devices. So in a certain moment when it's searching now for the devices, should probably list the devices and then delete the already running script from the previous
tests and runs.
That we did together. So basically, the AI is working some kind of a human brain. So the gray part of your brain is LLM, so large language model, and it's processing the abstract information, the colors, the words, the sounds. And there's another network, another neural network, which is called large action model. So this is more like a small spine where actual I/O signals are prepared to be sent to the external part of the world. And the actual signals that is sent to the spine cortex is sent, and then to the hands and the legs, for example, are actually the tools that are generated from the large action model are Linux commands in my case. But for the one who is using Windows or Mac, for example, the commands will be slightly different because the local agent that is communicating with the operating system now is understanding what kind of operating system it is using and choosing, cherry picking the tools that will be later used for the actions that large action model is developed based on the thoughts of the large language model. So it's like a digital thinking process.
Yes,
yeah, it's
yes.
a digital thinking process. So now what if you're watching our screens while listening to us, you will probably notice that the scripts are stopped, started, again running, and it is making its own magic.
Yeah, just to recap, so basically in this prompt right now, we told the AI that we have these two devices, that they are connected to the same network that we are connected to. The AI to find those two devices. We also told the AI that we have 4 buttons connected to the i4 that we would wish to use as control, and that we need to use the Pro 4PM as the output device.
Yes.
Which is then in turn, this is the only thing that we didn't mention, you could probably tell, but the Pro 4PM is connected to the 4 light bulbs that you can see on the demo, which the goal is to have them turn on
and turn off. Yeah.
Yes,
so please note that this is a live demo. The things might fail on your side, on our side as well. Always watch the work that AI is producing, and the one who is more into the development part should know that as a developer now you should become more as a manager. So you're managing someone who is developing stuff for you, and you should monitor constantly what is the output of the production that you're developing.
Yeah.
I think it is almost finished. The scripts are running now, no errors into the console of the embedded web. So I'm waiting it to finish the job. I'm proposing to check after it's finished that it's working properly, and probably go to the Q&A.
Yeah, sure. We'll test it, we'll see. But that's what I wanted to say also, to emphasize it, that we wanted intentionally to do this without too much planning and scripting, in advance, because we wanted to show you live what the actual workflow is. Because it is an AI, of course. It is very important to use the correct prompts, but the goal in the end is to have the AI use plain English language and convert it into scripts, so that you, without any kind of previous knowledge about programming, can do this kind of thing. But of course, sometimes it fails, sometimes it succeeds. We will see.
I propose to check.
We'll see how close we are to being replaced or not by the AI agents.
Okay, so
Let's
we
see
will
what
need.
it cooked up.
Yeah, will you help me with the other two?
Of course.
So 3, 2, 1, and wow, it is light up.
We have light.
Yeah, we have light. So this is the main goal, and let's sum up some probably a philosophical way. What you're seeing now is not something special. It is just a narrative to help us to open the bigger conversations to people who are developing stuff, and especially integrating peripheral non-Shelly devices into our Shelly ecosystem. So for example, to create a HTTP request from the Shelly device to an external system or to a local system is a really big step in order to bring information to the Shelly ecosystem. And this helps to improve that we are open, and we would like to stay open and continue developing.
Exactly, yeah, because you could basically just have, let's say, just any kind of normal 220 volt peer sensor, let's say. It can be from an obsolete alarm system or whatever. You just connect it to the i4, use AI to write you a script, and connect the i4 with the connected 220 volt peer sensor to control your lighting, for example.
So the integration is the very big part of the JavaScript.
Yeah.
Another purpose, and I would like mostly to stay this into our community and drive by the community, is that the use cases will come from them. So we're proposing a really nice tool, and if you see yourself into this, or you can find a really nice use case for this particular technology, please describe it well, give it to the AI, point it to the device, and test it for a while. Probably in 20 to 30 minutes everything will be covered and it will work.
Yeah. So also something very important to say here is that we are showing you this now because, as you can probably tell from the first webinar to this webinar, we're actually building. We are building on top of the what we did in the first webinar, because there we showed you some very basic stuff. We showed you how to set up the prerequisites and everything. But now we actually made something work. We have a demo, and maybe in the next
I don't know.
the next episode, maybe in the fourth episode, I don't know, we're going to be building on top of these things as well. So yeah, we currently, we have set them to momentary. Okay, we reset the bugs, okay. Can we now make the AI, tell the AI to not have these buttons just turn on the lights while we're holding the button, because let's be real, that's not practical. I want to push the button, turn on the light to stay on, and when I press it again to turn it off.
I don't know. We will try. I will give the prompt to the AI and we will see what is happening.
Yeah, and here everybody can see that you're just gonna tell it in plain text, hey, now when I press the button, I need to hold it to turn on the light. I want to press it to turn on and press again to turn off. And we're explaining this in plain English, what we want to happen, what the goal needs to be, and from then on, the AI should do the job.
My narrative is a bit different from yours because we're different people, but I believe that the meaning will stay. So instead just switching on and off, please make it act like a toggle switch, all of the channels.
Yes. So now it's going to start cooking again?
Yeah, it's now cooking again. We'll see what is happening. Probably to increase the font will be a bit more helpful for our participants. Yes, and it's changing only on the one side. It is very important to understand when we have such a complex system, because it is complex system, to solve two separate operating systems with two separate applications in the face of the JavaScript, and the AI will decide on which side the changes should be done, and this decision can be influenced manually. Otherwise, it can be left automatically to be decided depending on the complexity of the system that is developed by AI itself. It's very philosophical, I'm sorry, but it is what it is.
Isn't everything these days?
Yeah.
But what I love about this kind of setup actually is that here you guys can see that we are connected with the AI to the devices. We're telling it what to do. It's doing it in real time, and you actually don't have to do much of anything. Because I had this in some of the trial runs that I did with other kinds of devices and stuff, where I told it I want this and this. It compiled the script, and then it told me, now use this script and go and upload it to the device. And I told it, that's why you're doing it. I told it, you go upload the script, and then it uploaded the script, and everything started working. And then when I might changes, it was already connected to the devices themselves, and it was doing changes in real time.
Please be more polite, because when the judgment day comes, I don't know what is going on.
I'm gonna be one of the first ones to go, to be honest.
Oh well, from my switch is working. How about yours?
Let's see.
Yeah.
Maybe the bulbs kind of reset.
Yeah, the bulbs kind of reset because we did play it. But at least the first and the fourth is actually following the orders. Of course, don't forget that. It's a live demo. Stop playing around.
Oh wow.
So basically, we did achieve the specs. Very important thing. If you don't like how the demo is working, you can always describe what you don't like. And if you don't like the process of how application is working, please note that every physical system has its own limitations. So it is very important first not to blame that it's not working. Understand where the system limits are. And if you don't like the reaction speed, probably something else is going on. Read the documentation, learn more about the devices. Yes, it's very easy those days, but again, the limitations will give you a worse experience if you don't follow them.
Yeah. I also want to say something on this topic also, that it's also very important just to troubleshoot sometimes, because for example, while I was setting up, as I said, some of these demos, what actually happened is that I'm telling the AI that he's on this network, I'm on this network, the devices are on this network, and so on, and he was only able to find one of the devices. And I start troubleshooting, and what do I find? One of the devices had very outdated firmware, so I needed to update it first. I updated it, it connected to the internet, the AI found it right away. So as already said,
But you updated with the AI?
No, I updated it manually just in case, but this is something that you can try to do, I'm presuming.
So you're telling me that they're with latest updates?
These two devices currently are with the latest updates. Maybe you can check that.
I'm not
Maybe
sure.
You can check that. I'm also not sure. Maybe
I've seen the installation for the first time yet. Yeah. Tell me the firmware of the Shelly devices, please.
Yes, please. That is very important.
Yeah.
Yes.
And
can you imagine the robots going around and they're like, this guy was not nice?
Because he doesn't write please when it's... Yeah, it's 175. Yeah, this is the stable one. Yeah.
Yeah, very nice.
Perfect.
Very nice.
So, wow. And well, basically we're done. So maybe people are asking some stuff.
Yeah,
let's check what they want to see from us.
Honestly, this was genuinely impressive. I mean, I want to just everyone to take a second and appreciate what just happened, because everything happened very fast. A lot of stuff happened, and it really didn't look like that much. But we described what we wanted in plain language to the AI. The AI wrote the script, which, as probably many of you know, scripting is not something that's generally very easy to do. That's a very complicated job, and even a small script at first glance like this can actually be quite complex, because it can contain a few lines, but those lines can be very important and need to be absolutely correct. So the fact that two devices have absolutely no physical connection currently to one another, and they are now talking to each other, this was live in front of so many people. I mean, that's not.
But this is happening all the time with all the wireless devices.
That is also true, yeah. But yeah,
so maybe more devices we should include, and the magic will scale up, I believe.
Let me start checking now for any questions. I hope you guys prepared and loaded the questions.
Yeah, shoot us with questions.
Okay, I see some questions right away. Okay, does the agent know the memory for scripting, limitations of the device? As for example, in Matter mode, it reduces memory available. So I think he's asking if the AI will know the size of the memory for the scripts, and if it will try to exceed them and just keep them as a reference, the size of the memory. Are you going to ask the AI if he does know that?
Of course. Yes. So the first answer...
Who better to answer that than the AI itself?
So the first answer would be our colleagues from the development team just create an MCP server that can answer all of this kind of the questions. So all technical questions can be answered now by the MCP server.
Yeah.
Of course, our AI agents can scan the devices, and if you're seeing my screen, basically the AI agent is make a call to the devices and answer the questions with the real numbers in bytes. So does it know the size of the memory? Yes. Why? Because the API gives the ability to read the memory size. So if I ask the AI to give me this information, you can see it on my screen that it is structured the way it can be human readable.
Yeah. Perfect.
So the answer is yes.
I have a very interesting question here. This is of course very nice, but not all clients use Shelly only. They could use other brands and therefore also other systems like Homey or Home Assistant. How would you use this tech to merge all of this together and make it work like one system? So I actually have one example from my own home and my own devices. I have a split AC system with Hisense ACs. And actually I use the dimmer because it has...
because you have dimmer.
Because I have a dimmer. And told the AI, I want, because the Hisense ACs, they have their own API, they have an open API, which is very important. Their cloud has an open API, but they also have their own app. But you know, I don't want to use one app, the Shelly Smart Control app for my smart home, and then have a separate app just for my ACs. In my opinion, that's just not very optimized. So I wanted to do this kind of integration. So I told the AI, hey, I have these ACs. They are connected to my network because, of course, they have the app. They need to be cloud connected. They are connected to my network. These are their IP addresses. Or no, I even told the AI that I don't know the IP addresses to see if it will find them. After some trial and error, yes, it did find them. And I told him, I want to be able to control these ACs from my Shelly Smart Control app. It wrote a script, made virtual devices of the AC controls themselves. So now in the dimmer memory is leaving a script that is actually calling a proxy that I have. It's calling the Shelly Cloud. The Shelly Cloud is calling a proxy that I have, and the proxy is calling the
I just prepared,
API.
Yeah, I just got what you're saying on my screen, so we can show my screen now and what you're describing.
Yeah. And as you can see here, this way you have the on-off controls, you have the mode controls, and you have the temperature controls.
Which is the most common controls for every AC system.
Yes, exactly. And all from one app, from one place. And this is living on the memory of another Shelly device. To me, that's
to
crazy.
extend what you said, I continue answering this question. I had the same system, but for Mitsubishi. And I have, again, the same virtual components that are describing the state of the entire AC system. And I am using Tasmota and NeoCoolCam infrared blaster that is with Tasmota infrared firmware. And the Shelly script is synthesizing commands, and the Tasmota is synthesizing infrared commands. And because the virtual components are living now into the Shelly ecosystem, I can automate everything, and of course I have it in my pockets. Is it possible? Yes, it is possible. This is why in the end I said if we can create an HTTP calls, a lot of options can be.
And I just want to add that in this case, the proxies that we're talking about, the only reason that you need this kind of proxy is because we at Shelly, of course, don't currently have a cloud-to-cloud integration with Hisense or Mitsubishi. So that's why you need something like that, but there is many instances where
sounds like a roadmap.
I don't know. But that's something that you won't even need in every instance. So there is many cases where you get a very clean integration just with the script because of the AI.
Of course, if you have a cloud-to-cloud integration, we're proposing to use this because it's faster and
it's
more
much
reliable.
Better and polished.
So don't forget that the Shelly device is a small computer, and the cloud-to-cloud integration is a serious task. Okay, so the next question probably.
Let me see, this is actually a question. So Shelly scripting is an absolute game changer. I use it at just about every installation and it's truly revolutionary compared to the competition. The only limitation is your imagination. Keep up the good work. Very nicely put, Werner. I'm sorry if I'm not saying your name correctly. Thank you for the nice words.
So basically the JavaScript into the Shelly is like a hammer. Everything around is a needle and you can...
Let me see. I would love to be able to add more than 4 scripts.
You can add as much as you want depending on the Shelly flash size, because the file system of the scripts are living into the flash. Because when you shut down the Shelly physically from the circuit breaker or from the switch, it should keep holding it. Don't forget, very important for our ecosystem, the newer the devices, the powerful processors and the bigger the flash sizes.
Gen 4 devices, for example, have quite a bit more memory than Gen 3 devices.
And the Gen 5 will have even more. Sorry?
Gen what? I don't
know. So, what?
Let me see if we have anything else. Currently, I think it's more of a conversation, but wait.
Is someone cursing on us?
Not yet. From Pedro, any way to integrate the agent on Google Gravity? Do you know?
I don't know. I want this answer to come from him, or if he have some good results to share us back, or share it on our Facebook community, because this will be helpful. I'm from the Google products now. I'm using only Gemini. It is helpful as the ChatGPT is, but I use it for slight different purposes. Probably it will work. I don't know. Help me to understand.
We already have questions about Gen 5. What
Yeah,
did you do?
I don't know.
Okay, Jap, I think he's following up on the question that he had. But what I mean is that some clients want to use the WoW Display XL as the main control, but they have other stuff. How would you solve that issue? Scripting could help. So you can do like a mix of, let's say, Home Assistant, Shelly scripts, and so on, because Home Assistant, you can use it to integrate many
like a data hub.
brands. Yeah, like a data hub, basically. You can also use Homey. Homey has an excellent hub that has infrared. They have ER, I think it was ER433.
And my favorite 433 megahertz raw radio transceiver.
Exactly. So you can use a mixture of these things to create a very comprehensive control of your whole ecosystem. So it's not impossible to bring all of this together. It just requires some finagling sometimes. Let me see. HTTPS server .register endpoint without using script number? Question mark. I'm not sure if I understand the questions. Werner, if you can rephrase it.
Give it to the AI. Tell him to give it to the AI. It will help.
Yeah, I see we have the link for the Facebook community group. That's an awesome place to be, by the way. I always say it because there is so many people active there. There is more than 120,000 members currently there. One of the people that is very active, actually one of the most active people there, which is very interesting, is that our CEO Dimitar Dimitrov is there. He's constantly sharing ideas. He's constantly building on some leads and stuff, and he's always sharing about his personal projects, which are very interesting. And also many of Shelly employees are active in that group. So, oh wow, I see somebody pasted the whole script.
Okay.
Yeah. Oh no, the HTTP endpoint.
It's fine. I want to summarize something for the JavaScript, and I don't see any reason to lose more time for this particular episode. The JavaScript is an instrument in its core that allows you to create automations if you don't have hub, because the philosophy of Shelly devices is to be hubless. It is very good to have Node-RED around. It is very good to have Victron TurboGX module that is giving you automation. It's very good to have a Homey. It is very good to have a Raspberry Pi with some shell scripts. But if you are not able to have a central computer, most of the automations can live into the Shelly JavaScript, and visualization can be done with the virtual components. So the main idea behind JavaScript is just to have automation option and visualization option of the data to systems that are not centralized. So even if you lose if you lose a central computer, the things are continue working all together. Yeah. So I don't have anything to share anymore. Probably for the I will left some for the next episode.
Yeah, I think that's a good thing. So I see we have one last question. I think one of the last questions at least. How can you be sure that the AI won't try to overwrite an existing script? The honest question, I think, is that you can
ask him. Yeah, ask him. Check for another script that is doing the same. It will use the HTTP interface to download the script, to check, to compare the file logics, and then
to make sure that first of all he's not overwriting a script, and just tell him that he first needs to make sure that there is enough space for the script.
Of course,
and just to make sure that he doesn't overwrite something that shouldn't be overwritten. So that's going to be enough of a guideline for him to not make any kind of crucial changes.
The second rule that we wrote for our prompt is delete all existing local scripts from both devices.
Yeah, to scrub them, to go grab the broom.
For the same problem that is described in the question, add a rule that please check if there are conflicts or other scripts that are doing the same job, and then you're ready.
Exactly. Okay, so the agent can access the devices. Can it analyze outside script scope? That is, can it read status, energy, etc.?
Yes, it can. If you have it in the API, you have it into the
exactly.
AI.
Exactly. If it's a component, if it's a characteristic, whatever, it can be visualized and it can be read. Yeah,
of course.
Well,
I
Okay,
think.
great. He's saying great. I think
Oh,
he liked
thank
the
you very
answer,
much.
yeah.
Yeah, thanks to the API, not to us.
Yeah, some fantastic people behind the embedded web and
Of
everything.
course.
So everything just came beautifully together.
Well,
Okay, I'm currently not seeing any more questions. I hope everything is clear enough. I hope it was not too much information and that's why there are not too many questions. But even if they are, you can guys always save them for the third part of our scripting with AI. So feel free to, if you come up with any questions, just share them next time with us. So amazing. I had an amazing time personally. It was very fun to watch the AI do the stuff, do the work for us. It was very nice seeing the demo actually come together live. I actually was prepared, honestly, to have a fail. So I wanted to be prepared for that, but everything came amazing. So thank you, everyone.
Fire.
Yeah, nothing caught on fire on live television. So yeah. Again, thank you guys for joining us. Stay tuned for our next webinar, and you can watch this recording in a couple of days on our Shelly Academy YouTube channel or the landing page in shelly.com. So, thank you guys. Goodbye, everyone. Have a good time.